Electricity. We think of it as something familiar and even mundane. The light bulb flashes on, the kettle boils, the phone charges, and everything seems simple and understandable. But as soon as you start to look into it, the familiar picture crumbles. Physicists still cannot answer the main question. What is electricity at its most fundamental level? Behind every discharge, behind every current, there are phenomena that terrify even scientists. Electrons behave like rebels, violating all the laws of logic. A vacuum, which should be empty, suddenly produces sparks. Even our body is an electrical machine that can deliver an electric shock at any moment. And the more we study the nature of electricity, the more we understand that we are dealing not just with a technical tool, but with a force capable of changing the fabric of reality. Today, we will discuss some facts that are truly unsettling. When we talk about electricity, our imagination most often conjures up images of lightning or light bulbs. But the roots of this force go much deeper, right to the heart of the atom. It is there, at the level of electrons, that this phenomenon is born. An electron is a tiny particle that, for some reason, can do things that defy common sense. Instead of quietly revolving around the nucleus, it behaves like a ghost, not occupying a clearly defined place, but existing simultaneously in different states. Scientists talk about the cloud-like nature of the electron. It is not a point, but rather a fog, a probability, or a quantum shadow. And it is from this strange behavior that electric fields and currents are born. The paradox is that the fundamental unit of electricity is itself incomprehensible. When an electron jumps from one orbit to another, it does not move along the usual trajectory, but disappears in one place and appears in another. This is a quantum leap, instantaneous and illogical. At the same time, energy is released in the form of a photon from a particle of light. What we perceive as electric current or lamplight is actually born from this dance of electrons and photons on the verge of madness. Physicists have long tried to tame this phenomenon. The classic picture of electrons traveling through wires turned out to be just a convenient illusion, behind which lies a much more terrifying truth. Electricity is not a flow of particles, but an interaction of fields, vibrations, and quantum jumps. In essence, every day we use a force that is based on a mystery that even 21st century science cannot fully explain. If electricity is born from quantum jumps and the unpredictable behavior of particles, can we even say that its nature is understood, or is everything we know just a mask covering chaos? Lightning is not just a beautiful picture in the summer sky. It is a giant electric whip, whose strike can split trees, vaporize metal, and even turn the ground beneath your feet into glass for a moment. Scientists still admit, despite decades of research, that lightning is a mystery. To understand the scale, imagine that the voltage in a thundercloud can reach hundreds of millions of volts. At the moment when the discharge breaks through, a current of tens of thousands of amperes passes through the lightning channel. This is enough to heat the air to a temperature several times higher than that on the surface of the sun. A shock wave instantly forms around it, and then thunder rumbles. But that's not even the scariest part. Physicists are still puzzling over how exactly the lightning channel is formed. The discharge can be reproduced in a laboratory, but what happens in the atmosphere is much more complicated. Sometimes lightning strikes nowhere, hitting empty space. There are ball lightning, plasma spheres that live for a few seconds and behave like living beings, flying through walls, moving against the wind, and disappearing without a trace. There is still no single theory that would explain their nature. It is even more frightening to realize that such impulse discharges occur not only on Earth. Space observations have shown that the upper layers of the atmosphere are raging with so-called sprites or elves, giant flashes that break through into space. This means that electricity on the planet is only the tip of the iceberg of enormous processes associated with the cosmic electric ocean. Every time you see lightning outside your window, remember that it is not just a beautiful light effect, but an instantaneous burst of energy equal to the explosion of an entire bomb, which arises literally out of thin air. And the most alarming thing is that we still do not fully understand how it works. Electricity usually behaves predictably. Current flows through a conductor, and some of the energy is lost as heat. This is what causes light bulbs, kettles, and even the wires themselves to heat up. But when metal is cooled to extremely low temperatures, something so strange happens that even physicists have acknowledged it as miraculous. Resistance disappears completely. Electricity begins to flow unimpeded, without the slightest loss. This state is called superconductivity. At first glance, it seems like a blessing. Energy is not dissipated and can be transmitted over 1,000 kilometers without loss. But in reality, the picture is much bleaker. Phenomena occur in superconductors that resemble a nightmare come true. Magnetic fields, when in contact with this state, begin to behave wildly and unpredictably. Their lines bend, break, and pull inward, like funnels. This effect is called the Meissner effect. It looks as if the metal repels the very nature of magnetism. There is also a critical temperature and a critical field. If the conditions are disturbed even slightly, the system collapses. The superconductor instantly loses its incredible properties, returning to its normal state. And this transition is accompanied by colossal energy surges. Imagine a current flowing through a superconductor ring that can circulate indefinitely, but the slightest disturbance is enough to release energy in a catastrophic way. The most frightening thing about this story is that there is still no single theory that explains the nature of high-temperature superconductivity. Why do some materials suddenly lose their resistance when cooled, while others remain normal? Why do electron pairs, known as Cooper pairs, begin to move like a perfect army of frictionless particles? Physicists admit that we observe the effect, but we cannot yet fully explain it. If electricity is capable of completely changing its behavior under the influence of cold, then perhaps it is subject to laws that we have not yet discovered. A vacuum is a symbol of absolute emptiness. We are used to thinking that if there is no air, then there is nothing that can conduct electricity. But this is where the most interesting thing happens. Discharges can occur even in a vacuum. Imagine that a voltage is created between two electrodes in a vacuum chamber. It would seem that the discharge volume should remain silent, but suddenly a bright arc flashes in the void. Where did it come from? With sufficient voltage, the quantum nature of the vacuum itself begins to work against us. Electrons literally break out of the metal surface under the action of an electric field. This process is called electron emission. The void turns out to be not so empty after all. It is full of virtual particles that electricity can pull into reality. That is why engineers working with particle accelerators, spacecraft, or microchips fear vacuum breakdowns. A single such discharge can disable sophisticated equipment, damage a satellite in orbit, or even cause a catastrophic failure in a space mission. A flash in a vacuum develops so rapidly that no protection can respond in time. Physicists are particularly concerned about another frightening prospect. In extremely strong electric fields, it is possible to create particle-antiparticle pairs directly from a vacuum. This phenomenon is known as the Schwinger effect. In essence, the void begins to give birth to matter under the pressure of electricity. Just imagine an electric field powerful enough to literally create particles out of nothing. So electricity in a vacuum is not silence, but a mysterious and deadly process that reminds us that emptiness is not empty, but rather a hidden trap, ready to spring at any moment. Matter exists in three forms: solid, liquid, and gaseous. But in fact, most of the universe exists in a much stranger state: plasma, which is rightly called the fourth state of matter, and this state is not just unusual, it is frightening. In plasma, electrons leave atoms, turning matter into a chaotic soup of charged particles. And here, electricity plays by its own completely insane rules. Unlike the materials we are familiar with, plasma exhibits collective behavior. Electric currents in it do not flow through wires, but create powerful vortices, discharges, and self-sustaining structures. It can form giant electric loops, hold colossal energy within itself, and react to the slightest external influence. Sometimes it seems that plasma behaves like a living being, resisting, adapting, and creating forms that are impossible to predict. The most alarming thing is that plasma surrounds us everywhere in space. The sun, lightning, auroras in the atmosphere, even comet tails. All of these are manifestations of the electrical element in its wild form. On the sun, plasma emissions can reach the size of several Earths and release so much energy that when they hit our planet, they can destroy the electronics and energy systems of entire countries. Even in laboratories, plasma remains uncontrollable. For decades, scientists have been trying to tame it for controlled thermonuclear fusion, where plasma energy could replace oil and gas. But every time it breaks free, magnetic traps break, currents explode, and the system collapses. Physicists call such events plasma disasters. At these moments, it becomes clear that electricity in plasma is not just a force, but a whole element capable of turning from an ally into a deadly enemy at any moment. In the most frightening discovery, sometimes plasma forms strange formations that resemble living objects, such as ball lightning and plasma rings. These are all real phenomena that we do not fully understand. They are born from electricity, live their own lives, and disappear as suddenly as they appeared. Who said that matter must obey the laws we are familiar with? It seems that insulation is our armor against electricity. Plastic, ceramics, glass, or air. These are all familiar materials that should reliably contain the current. But every barrier has its limits, and as soon as the voltage exceeds a critical value, a dielectric breakdown occurs. In an instant, the material turns from protector to traitor. It begins to conduct electricity. The physics of this process looks frightening. During a breakdown, electrons, like crazed bullets, begin to accelerate in the electric field, collide with atoms, and knock out new charged particles. An avalanche occurs, which grows at a frantic speed. In the air, this results in lightning in solid materials, cracks, flashes, and plasma channels capable of splitting the insulator from the inside. Imagine that what is supposed to protect suddenly turns into a source of destruction. It is even more frightening to realize that a breakdown can occur completely unexpectedly. Sometimes a microscopic defect in the structure of the material, the slightest bubble of gas or speck of dust on the surface, is enough. In the laboratory, it looks like a sudden flash, and all the equipment is disabled. In everyday life, a breakdown can lead to fires, conflagrations, and even explosions. But the real horror begins on a cosmic and energy scale, in high-voltage transformers, power lines, or spacecraft systems, where a breakdown can cause a cascade of disasters. In an instant, the result finds a new path, destroying equipment that was supposed to last for decades. Scientists also note that a breakdown is not just a technical failure, but a manifestation of a profound truth about electricity. The force that we are accustomed to considering controllable is always looking for a loophole, always ready to break out, destroying even the most solid defenses. And this reminds us that electricity is not a hand tool, but a wild element that only allows itself to be used temporarily. Ferromagnetic resonance is like a secret ritual performed inside the tiny magnetic moments of atoms. When the external magnetic field and high-frequency oscillations coincide with their own song, a strange phenomenon begins. The spins of electrons suddenly begin to precess in sync, as if captured by an otherworldly rhythm. This invisible dance, reminiscent of a seance, not only fascinates scientists, but also allows us to glimpse into the depths of ferromagnetism. From a scientific point of view, this phenomenon is a fine-tuning, where the field and frequency, like a key and a keyhole, fit together perfectly. But its effect can hardly be called a harmless resonance. On a microscopic scale, such vibrations can increase heat loss, destroy the stability of materials, and lead to chaotic processes in electronics. Devices operating at the limits of their capabilities literally hear this resonance, like a ghost disrupting their usual order. Today, ferromagnetic resonance is being studied not only as a threat, but also as a powerful tool. With its help, it is possible to read information about the structure of solids, control spins in quantum materials, and even design new memory technologies. However, every time scientists turn on the generators and see strange peaks in the spectrum, there is a feeling that matter itself is responding to the call, as if there is something beneath the surface of the familiar world, ready to manifest itself with the right frequency incantation. The human body is not just a set of bones, muscles, and organs. A river of electricity flows through each of us, which we are almost never aware of. Every cell in the body maintains an electrical potential on its membrane, like a tiny battery. This charge allows nerve cells to transmit signals at a speed that seems fantastic. An impulse that arises in the brain in a fraction of a millisecond reaches the tips of our fingers. In essence, a thought is a flash of electricity. But the most frightening thing is that these microscopic currents create an invisible electric field around us. We literally walk inside our own cloud of energy, which pulsates in time with the work of our heart and brain. Cardiographs have long been able to capture these weak electrical fluctuations, turning them into graphs. However, experiments in recent years have shown that our bodies emit far more signals. For example, the heart generates an electric field that can be measured at a distance of more than a meter from a person. Incredible. This data raises an alarming thought. If we are constantly surrounded by our own electric aura, can we unconsciously interact with the fields of other people? Scientists are cautiously discussing the phenomenon of so-called bioresonance communication, when bodies in close proximity exchange very weak electrical signals. And although official science remains skeptical, some experiments suggest that even our emotions can change the nature of this radiation. It turns out that we are charged without even knowing it. Our bodies are not just mechanisms of flesh and blood, but also living sources of electricity whose invisible energy connects us to the world around us. And perhaps when we sense the presence of another person before we see them, it is not mysticism, but the action of invisible electric fields. Ultimately, electricity is not just a convenient tool that lights our homes or powers our gadgets. It is a force hidden at the very heart of atoms, in the void, in plasma, in our every bioelectric potential. It can break through insulation, generate lightning and cosmic flashes, and accelerate electrons to speeds we can barely imagine. Every time we turn on the light or charge our phone, we are using a phenomenon that physicists still do not fully understand. Frightening facts about electricity show that it is something much more dangerous and mysterious than it seems at first glance. It lives by its own rules, disrupts our understanding of order and stability, connects the macro and micro worlds, and sometimes manifests itself almost like an intelligent being. That is why the study of electricity remains on the borderline between science and mysticism. Each discovery brings new questions. How can we control this force without risk? What other secrets does the universe of electric fields and quantum leaps hide? And most importantly, are we ready for the fact that our understanding of familiar things is only the tip of the iceberg, behind which lies the chaos that controls the very fabric of reality?